My research focuses on atmospheric aerosols, and it has several major areas: aerosols as they relate to visibility, as they relate to global climate, and that includes how aerosols interact with clouds in the atmosphere, both warm clouds and also cirrus clouds, cold ice clouds. So we look at aerosol physical characteristics, try to understand where in the atmosphere they came from. For example, if they're long-range transport of dust, or if they came from smoke from wildfires, if they're pollution sources. We look at their physical properties, how they take up water. That has a very big influence on visibility. It also affects climate. And then we look at how they freeze. So certain species in aerosols may freeze under warmer or colder conditions, and that will affect the regions in the atmosphere at which cold clouds form. And that has a subsequent impact on climate. So there are a lot of tie-ins to global climate that we trace back to the aerosol end of things. We're doing visibility research with the National Park Service. We've been doing that for a number of years now. And what's been most recent interest is smoke from wildfires and also from prescribed fires, because the amount of prescribed burning is going to go up as far as management policies change. So there's a need to understand what that will do to visibility in the national parks and elsewhere in the U.S. because the smoke is transported around the country in some cases. The freezing research, I think, is particularly interesting. CSU at the present time is the only group in the world that has an operational counter to measure ice-nucleating aerosols in real time. And we've deployed that on the ground and also in aircraft. Made some very interesting measurements, pretty much the first of their kind, and learning a lot more about what makes good ice-nucleating particles in the atmosphere. Another thing that my group has been getting involved in is remote sensing of aerosols. Because there's so much interest in global climate and climate change issues, there's a real need for observations on a very large scale. And so the way to do that is from space. So a lot of the new instruments that are going up are really designed to look at aerosols, different aspects of aerosols, and now aerosol cloud interactions, which is one of the things we're very interested in. I think one of the great things about our department is that atmospheric chemistry is located in an atmospheric science department. That's fairly unusual if you look at programs around the country. And why I think that's a benefit is that so much of what we do ties into climate change issues, remote sensing applications, things where there's other excellent expertise in our department, and our students are able to benefit from that. And plus they see it as part of their education, so they get a very well-rounded background, not just in chemistry, but in the bigger picture of atmospheric science. And I also think it's great to be in the Front Range of Colorado. There's a lot of resources, some excellent labs and programs down in Boulder that they can draw expertise from and interact with. So I think that's a big plus too.